to all of you to the Global Women Tech Network Conference 2022. I'm Richa Daga. I'm a technical speaker, author, mentor, and an engineer by heart. I'm passionate about technologies and chipsets that connect the world. I'm working as a software engineer at Cisco and have a decade of experience in development of packet optical products that are building the internet of the future. I'm really excited to get this wonderful opportunity to interact with all of you here, people who are as passionate about technology and believe in advancing the cause of women in tech as I do. So please join me for this session to take a journey into network modernization for 5G and beyond. In this session, we will cover 5G service types, the evolution challenges in the way of 5G, insights into radio signal processing stack and edge infrastructure, and most importantly, the need to upgrade networks by designing a new fabric architecture for making 5G possible. So 5G is the fifth generation of cellular technology and is getting widely deployed around the world today. So let's understand what all is possible with 5G coming in. So these are the use cases that you can see on the screen. Mobile broadband. It addresses the human-centric use cases of 5G for access to multimedia content, services, and data for better and faster connectivity to handle higher quality video content. So, EMBB, that is enhanced mobile broadband, is a natural evolution to existing 4G networks that is faster and will provide a better user experience than current mobile broadband services. The key criteria which is enabled by this use case is seamless coverage. So the use cases for EMBB are like video streaming. So I think the way you and I are interacting today is video streaming. So that becomes faster and more effective when 5G comes in. So lightning fast browsing, such use cases are important, which are enabled by enhanced mobile broadband. But do you think that these use cases are mission critical? For instance, if network latency occurs and results in an additional half second to download a video or render a web page, it will probably not ruin the customer experience. But in preventing a traffic accident or running an industrial robot, that half second becomes so important. So, in scenarios like those, delay and failure are not an option. So that's why come the next use case of 5G, that is ultra reliable low latency communication. Your LLC can support real time mission critical communication like autonomous driving, industrial robotic automation, and emergency disaster response. So the tactile response time with this use case is expected to be less than 1 millisecond. So this use case has stringent requirement for capabilities such as throughput, latency, and availability. Some examples that fall in this category are wireless control or of industrial manufacturing or production processes, remote medical surgery. So I think this is one of the use cases which we have been thinking a lot during the pandemic, like if we can have remote medical surgeries taking place, and that can only be enabled if there is ultra low latency in communication. So smart grids, transportation safety are all enabled with this use case. The third use case is MMTC, that is machine type communication. This is the key technology needed to scale up the Internet of Things from its current limited use to its general use by enterprises and even the public entities. So this can help to achieve massive Internet of Things. MIoT can serve, that is massive Internet of Things, MIoT can serve billions of low cost, long range, and energy efficient connected devices across remote applications as well as cloud locations. So now coming to the main point. We discussed about these 5G service types. This is everything that is the magic of 5G which is brought to us. But why are we talking about network modernization? So what is the need of it? Aren't our existing networks enough to achieve all of the requirements of today's digital world? So I believe not. Here are some of the statistics. by 2023, if you would imagine, 66% of the global population will be connected to the internet. So if so many of the users will be connected to the internet, you can imagine the amount of bandwidth that is required to support all of them. And global fixed broadband speed will reach 110.4 Mbps, and connection speed will reach 575 Mbps in 5G. So the networks are facing, they are on the verge of facing unabated growth, and hence there comes the need of network modernization. So what did you think? Like augmented reality, virtual reality, IoT, artificial intelligence, edge computing, all the latest technology, all the buzzwords that you have been hearing a lot. Nothing can't survive without bandwidth. So which is possible if we have robust networks. So the successful operators which you see, they run profitable businesses that rely on revenue from attractive service products that address both the consumer and the enterprise market. So today's consumer products, they integrate voice and data playing, whereas enterprise products tend to focus on the needs of businesses. So increasingly, operators are giving us capabilities that allow other businesses to use the network. So network requirements are everywhere today. So 5G networking is designed to address service creation capabilities with features in both the radio access network known as new radios and the 5G core network known as 5GC or the 5G core. So everything, if we have been talking about network modernization, why? The question always is like, if we want to understand anything, we should always go into the depth that why is it required? It is required because obviously there would have been some challenges in evolving to 5G. The promise of 5G is of a system integrating with the new radio interface that is defined for a broad variety of use cases. So the network, it has to offer lower operational expenses, that is OPEX, and better control over CAPEX costs throughout the mobile supply chain. So a monolithic functional implementation, such as the base transceiver station, is an example of why the current mobile supply chain is outdated. So with this implementation, operators today had to pick one vendor per market. But you know, if there's no competition, there's no demand of vendors which is there, we get resoluted to only one single vendor which is available. So this happened, and we had a limited set of applications that the operators can provide to their customers. So sometimes these vendor dependencies and lock in can propagate into other domains when proprietary features are implemented. So that's why to solve all of these problems came the software defined attribute of the emerging 5G solution set. So if a mobile network operator, if it embraces the principles of disaggregation and decomposition, that can have software defined attributes. So both of these principles are at the heart of what it means for a network to be software defined. It means that software is a separate purchasing decision from the hardware, and that commercial off the shelf hardware are used wherever possible. So decomposition, it means that the network architecture is built from modular elements that assemble into a whole through open and interoperable interfaces. So that's why this helps to get over the existing problematic closed RAN. So with the help of Open RAN Alliance and by employing the principles of software disaggregation and leveraging decomposition, which in the 5G system architecture is an attribute of both the radio access network as well as the core, it is possible to build an optimal architecture that addresses the OPEX and the CAPEX challenges. So this new RAN cloud architecture, so at the time of 4G, we had 4G radio access networks, which were distributed RAN. But coming to the 5G, we have centralized RAN. So this new cloud RAN architecture, it addresses the challenges of building multi-vendor networks and harmonize to a common feature set. So one fundamental characteristic is the decomposition of the radio signal processing stack using standardized splits. So if you would see and understand here, the radio signal processing stack decomposition It maps functions in the stack as follows. That is Service Delivery Adaptation Protocol, or SDAP. It is in the new radios, in the NR only. Packet Data Convergence Protocol, that is the PDCP, and Radio Resource Control, that is the control functions, are mapped to the centralized unit. These stack functions are packet level manipulations that aren't timing sensitive and can be easily implemented in a virtualized environment. The mid hall links. So, if you would be hearing about cross hall architectures, so they have also come into place when 5G came in, where the network divided into front hall, mid hall, and the back hall. So, the mid hall links that connect the centralized unit to the distributed units are defined. CU location is excellent for deploying user plane functions, that is the UPF, in the decomposed packet core architecture. The decomposed packet core is known as the CUPS, that is the control and user plane separation in 3GPP release 14 and 5GC in 3GPP R15. The radio link control RLC and medium access control MAC and the file layers map to a distributed unit. The DU performs significant preparation for the RF layer, including rate adaptation, channel coding, modulation, and scheduling. So the baseband radio functions, up and down conversion and amplification, along with analog beamforming map into a remote unit deployed at the cell site, are known as the remote radio heads. So if you would see what happened used to happen in 5G, we had a BBU that was the baseband unit. But with the coming of the 5G CRAN, that BBU became decentralized and disintegrated into distributed unit and centralized unit. So the interface that was existing previously used between the radio unit and the BBU was the CPRI, that is centralized packet radio interface. But this CPRI cannot be enhanced and used for the 5G architectures because it cannot cater to the huge bandwidth demand that 5G brings in front of us. So that's why came into the picture eCPRI, which is used in the front hall networks. So if you would see here in the next slide, this is the edge infrastructure. This is this enables us to achieve the ultra reliable low latency use cases of 5G. So the decomposition and the disaggregation of 5G, which were the software defined networking attribute, they only enabled a major architectural shift to an edge infrastructure that combines decomposed subscriber management with access functionality. So as the RAN and the core become decomposed, it became logical to create an intermediate location. This location would consolidate the centralized unit workloads and a user plane function from the mobile core. So you can see here, this is the edge cloud in the figure, and I think this edge cloud deserves a complete separate session of its own if I would want to describe what it is. But the point is that because of the 5G having software defined attributes, the edge cloud became possible and it facilitated offloading and enabled local virtualized services at a metro level. So these are the interfaces that I explained in the previous slide. If you would see here, that is the 4G CRAN that had the baseband unit. But with the 5G coming in, this baseband unit become disaggregated and decentralized into the distributed unit and the centralized unit. And the link between them is called as the front hall. The initial link that describes the link between the radio unit and the distributed unit is the front hall. And what we need today in network modernization is eCPRI to support it. So if we move further, as we talked about the edge, so the attribute of the edge actually is bandwidth reduction. So it performs computation at the edge itself to reduce bandwidth. And for example, for virtual reality applications, if you would see, the edge can compute a field of view that would otherwise have to be computed from massive amount of data associated to all the possible horizontal and vertical fields of view. So in edge computing, the operator deploys a 5G core user plane function, that is the UPF, and strategically located parts of the network where a hosting environment for the cloud computing is also deployed. So the same cloud environment can support the 5G infrastructure workload, such as the upper layer of the new radio signal processing stack, as well as the UPF. So, this new fabric architecture that we talked about, which becomes of prime importance, is it supports the horizontal scaling of a virtualized RAN infrastructure and provides a cost effective scaling of high speed 10, 25, or 100 gigi interface that are needed to handle 5G speeds. So, this solution is differentiated with the use of segment routing. So this is another important criteria that needs to be understood that is coming up in the 5G world. That is the segment routing, which supports overlay networking, network slicing, and traffic segmentation within the fabric and in the transport network. So policies and intent can be encoded in the segment routing header and propagated throughout the network. So this is a simplified representation of segment routing through a MPLS network, and the benefits are such that the biggest packet networks in the world by node counts, mobile networks, are well suited to the benefits of the segment routing because segment information is embedded in the segment routing header at the ingress router R1, in which you will see. So it defines an explicit path to the destination router via intermediate routers, that is the R2 and R3. So SR, that is the segment routing, brought us a lot of benefits such as network slicing, addressing the network scale. It simplified the network for us and reduced the OPEX. Other benefits are it made the networks very resilient, providing fast rerouting and protection that is superior to the current levels of router protection. Network utilization became wonders because it helped us to effectively distribute load while guaranteeing bandwidth to mission critical applications. Network topology, it enabled the multi-access edge computing use case. So this is finally the summary of what all we talked about in this quick session, and that is that the cloud network has to be fully virtualized from the RAN to the core if we want to reap in the benefits of 5G. And with this disruptive architecture in place, we can enable applications such as fixed wireless, low latency services, and rich media. And all of this also enables mobile access, that is, edge computing infrastructure that enables the best possible user experience. So I've tried to sum all of this, that is, network modernization required for 5G in these slides. I know the technical session, we cannot cover all of these details associated in depth, but if you would want to know more about it, you can connect to me further at LinkedIn, and I would be able excessively eager to tell you what are the technological advancements that are happening in Cisco and the other companies, and what all is needed and what all is happening in the world of 5G to enable high speed bandwidths. And if you have any questions right now, you can connect to me with in the chat section, and I would be here to answer them. Thanks a lot for being with me here throughout this session. Thank you, Women in Technology, for giving us this opportunity to interact with like minded people who are so passionate about technology and advancing women in tech. Thanks a lot.